Hello and welcome to my show. It's time for another short episode just covering off on Brian's logic. Seems he's got this idea in his head and he's a little bit confused about the old train book. So let's have a quick look at this map and see what he's been getting up to. Starting with this particular one. On the way through here, he said, I used someone else's stuff to do conspiracy. And he's gone down this path saying, yeah, here's my map, blah, blah, blah. And he started doing some math. Now he's come up with this. There's a couple of interesting mistakes. So let's just swap to my whiteboard. I've got to fix up. Let's jump some things. There we go. Now we have a need to transition across the whiteboard. So first thing I really noticed about the way Brian did this is the simple fact that he looked at a particular map and he started drawing on it, and he probably didn't notice that he didn't use Sydney. Well, that's roughly where Santiago should be. And he's got a line that goes here and it changes colour that goes in. So all this math, but he's tried to do his calculations by using hours, followed by the degrees, followed by goodness. This is actually quite hard to read, and it's probably not the right way to do it. Now he's got a 25 nautical mile difference between these 2 points. Then he goes on inside all of this stuff, and he comes up with his internal index of 75 by 15. That's why that's on my thumbnail, because I figured that looked like a pretty good thing to look at. So let's go and have a look at something which I think will put us in place. From here. And we'll transition across back to our Chrome. Let's have a look at this by going to this. What I've done is I've reworked these calculations. I've got my UTC. I've got my latitude, which are both minus because it's south of the equator. I've got the two longitudes. This one is positive because it's to the east from the main meridian, and this one is west of the main meridian. The internal angle between those 2 points turns out to be 138. So how did I do that? I took 360 plus minus 70, which gave me 289. So I made sure everyone pointed in the same direction and got the difference between the two. So I calculated this out based on just the longitudes itself. So that matches the radial arms on the Gleeson map. Gleeson map, by the way, is a polar coordinate system. It's not a Cartesian coordinate system. Seems to be quite a bit of a misunderstanding about how it's being projected. But it turns it into polar. You go from centre out, so using radials like that, it's polar. Okay. The calculations to get the distance in nautical miles are simply 90 degrees because it's from north to the equator, minus the latitude, and since that's minus, then becomes plus, and becomes 123.7 degrees. There's the distance from the North Pole to Sydney. There's the distance from the North Pole to Santiago. Pretty straightforward sort of calculation. Let's put these numbers into a triangle calculator. We know one angle, we know two sides. Let's go forward. First one's 138.1214. Let's put a side in. 7.32, please. Now let's ask it to calculate it out. Well, this is interesting because this side is 13,000. What did he say it was? He really said that this is the interesting thing. So he's come up with these numbers right here. Let's go back to my whiteboard because this will be a little bit ridiculous. But with respect to what he said, there is no value here that even matches that value. He's come up with this 14,000 nautical miles. Now I've just calculated, assuming it's a flat straight line. It's not a flat straight line. That is a ridiculous amount of distance to try to cover by assuming it's just a train, on a flat plane. It would mean that you would need nearly 5 times the amount of fuel. You would be in the air for 5 times longer, or you have to fly 5 times faster. There aren't many aircraft that fly 5 times faster, Brian, so I'm sorry to do this to you, but it's kind of giving me this idea that probably need to be crossed somewhere between these two strips, beginning with this one.
What we have here is a failure to communicate. But with crazy distortions and logic contortions, you picked a fine time to be a dumbass.
Well, that's enough said, Brian. I think you've given us all a good laugh for the day. We really appreciate you doing so, of course. We couldn't work without you. Now, I've got one last little thing I need to play just for everybody to remember.
Somebody once told me the world is gonna roll me. I ain't the sharpest tool in the shed.